Massive cargo ship, or even a decommissioned Navy vessel, they can't just disappear. Some of them are longer than skyscrapers are tall, weighing more than 50,000 tons. Every year, the United States alone faces the question of what to do with hundreds of aging vessels. Military ships, tankers, freighters, and even cruise liners. The answer is one of the most mind-blowing industrial processes you'll ever see: ship recycling. Inside America's supergiant recycling plants, these floating giants are carefully taken apart piece by piece until what was once a proud vessel sailing across oceans is reduced to valuable raw steel. This isn't destruction, it's transformation. It's the final journey of a ship, but also the beginning of countless new stories. Powered by the recycled materials pulled from its frame. But before the first cut is made, there is a crucial step: preparation. Ships aren't just floating steel shells, they are filled with decades of fuel residue, lubricants, asbestos, plastics, paints, and in older ships even dangerous chemicals like polychlorinated biphenyls, PCBs. Leaving these inside would pose serious risks to workers and the environment. So teams of specialists go in first, wearing protective suits. They pump out leftover fuel and oil. They strip out wiring that may contain hazardous insulation. They remove asbestos from walls and insulation. They clear out refrigerants and chemicals. This stage can take weeks, but it's essential to making sure the rest of the dismantling process is safe and environmentally sound. Only once the ship has been declared clean does the real heavy work begin. Workers prepare massive cutting torches, cranes, and hauling equipment. The air is filled with anticipation, because soon, steel that once protected sailors or carried cargo across the Atlantic will meet the fire of plasma cutters, breaking down into manageable pieces. For many people, it's emotional. These ships often carry stories. Some may have fought in wars, carried humanitarian aid, or hosted thousands of passengers. But here in the recycling yard, emotion gives way to engineering. The focus is on safety, precision, and efficiency. What was once a proud ship is about to be reborn. Once the ship is stripped of hazardous materials, the real spectacle begins. Imagine a steel giant the length of the Empire State Building lying on its side. Taking it apart is nothing like breaking down a car. This is steel plate that can be 2 inches thick, welded together with military-grade precision. To cut it, workers use plasma torches, gas burners, and in some cases, giant hydraulic shears. The sound is deafening, sparks flying, metal shrieking as it's torn apart. Teams of workers climb scaffolding or hang from cranes, slicing sections of the hull into smaller, more manageable chunks. The process begins from the top. Superstructures like the bridge, funnels, and upper decks are removed first. Large cranes swing in, lifting away pieces that weigh dozens of tons. Every move is choreographed for safety. One mistake could bring down thousands of pounds of steel. Bit by bit, the ship's proud profile disappears. The tall stacks, once spewing smoke across the ocean, are reduced to scrap. The decks, once filled with crew or passengers, are cut apart. Finally, workers move down to the hull, the thick, reinforced belly that carried the ship across storms and seas. Cutting the hull is the hardest part. It's often done in sections, with each chunk weighing several tons. These are hoisted by cranes onto trucks or rail cars, ready to be sent to shredders or steel mills. Watching it, you can't help but marvel. A ship that once carried thousands of containers across the Pacific is now itself cargo, destined for a furnace. This dismantling process can take months. A smaller ship may be fully processed in 6 months. But for giants like aircraft carriers or oil tankers, the operation can last years. In Brownsville, one of the largest yards in the US, dismantling a single supercarrier produced over 100,000 tons of scrap steel. That's enough to build multiple skyscrapers. Not everything on a ship is just steel. Ships are treasure chests of materials. As the cutting goes on, crews separate different types of metal. Copper wiring is stripped from conduits. Aluminum is pulled from railings and fixtures. Brass fittings, bronze propellers, stainless steel piping, each has its own recycling path. Propellers themselves can weigh up to 20 tons and are worth hundreds of thousands of dollars in bronze scrap alone. Even the engines, massive diesel machines as tall as a 2-story house, are taken apart. Components are sold for reuse, while metals go into recycling streams. Plastics, insulation, and wood are sorted out. Some can be recycled, others disposed of safely. Nothing goes to waste if it can be avoided. A modern US ship recycling facility aims to recycle more than 95% of a vessel's weight. It's a process of triage. What goes to steel mills, what goes to copper smelters, what goes to secondary markets. The workers are not just cutting, they're sorting, recording, and ensuring that every valuable piece is captured. So what happens after the giant chunks of steel leave the yard? They're shipped to steel mills across the United States. There, the scrap steel from old ships is fed into electric arc furnaces. Temperatures reach over 3,000 degrees Fahrenheit. In minutes, the ship's steel becomes a pool of glowing molten metal. Impurities are removed, and alloys are added depending on the desired grade. That molten steel is then cast into billets, blooms, or slabs. These in turn are rolled into beams, sheets, or rebar. And just like that, the ship is reborn. Maybe it becomes the skeleton of a new skyscraper in New York. Maybe it's transformed into rebar holding together a bridge in California. Maybe it's rolled into plate steel for a brand new cargo ship. The cycle is complete, from sea to land, from past to future. Every ton of recycled steel saves about 1.5 tons of iron ore, 0.5 tons of coal, and reduces carbon dioxide emissions by nearly 2 tons. Recycling ships doesn't just recover material. It avoids the environmental costs of mining and refining virgin ore. Ship recycling is not without its risks. In some countries, it has been notorious for environmental pollution and worker injuries. But in the US, strict regulations ensure that the process is safe and responsible. Before any cutting begins, all fuels, oils, and hazardous chemicals must be removed. Wastewater is treated. Air emissions are monitored. Workers are trained and equipped with protective gear. This is crucial because older ships can contain asbestos insulation, lead paint, or PCBs. Mishandled, these could cause harm for decades. But in modern American yards, these substances are safely removed and disposed of in accordance with EPA standards. The goal is not just recycling, it's green recycling, ensuring that the process of rebirth doesn't harm the planet. Why is ship recycling so important? The economics tell the story. A single large tanker or carrier can yield over 50,000 tons of steel. At today's prices, that's worth tens of millions of dollars. Add in copper, aluminum, and stainless steel, and the value climbs higher. Multiply that by the hundreds of ships decommissioned each year worldwide, and you get a multi-billion-dollar industry. For American yards, this means jobs. Welders, cutters, crane operators, environmental specialists. Entire towns in Texas and Virginia thrive on the ship recycling economy. And beyond jobs, it feeds America's steel industry. The US is one of the world's largest recyclers of steel, and ship scrap is a key contributor. If you found this journey into America's supergiant ship recycling plants fascinating, make sure to subscribe to our channel. We bring you more incredible behind-the-scenes stories of how the world's biggest industries work, how materials are reborn, and how our future is built. Don't forget to like this video, share it with friends who love engineering and discovery, and hit the bell icon so you never miss our next deep dive. These rigs are not just machines, they are floating cities. Taller than the Eiffel Tower, heavier than aircraft carriers, and capable of withstanding hurricanes, 30-foot waves, and the immense power of the ocean. Inside them, thousands of workers live and operate in round-the-clock shifts, drilling through layers of rock, sand, and salt to pump out millions of barrels of crude oil that fuel our global economy. Today, we'll take you inside this incredible world. From the construction of these behemoths to the precise drilling process, from life aboard the rig to the high-tech systems that prevent disasters. This is the story of how engineers extract black gold from the depths of the ocean. Before we dive in, make sure you subscribe and hit the bell icon, because we've got more epic documentaries coming your way about the most mind-blowing industries that keep our world moving. Let's get started. There are different types of rigs. Fixed platforms, which are anchored directly into the seabed in shallow waters. Semi-submersibles, which float but are stabilized with massive underwater pontoons. And drill ships, which look like enormous cargo ships but house advanced drilling equipment. Some rigs operate in waters over 10,000 feet deep, farther and deeper than ever imagined possible just a few decades ago. Once assembled, these colossal structures are towed out to sea by a fleet of tugboats. The journey itself can take weeks. Upon arrival, they are anchored to the seabed with chains heavier than locomotives, or kept in position by dynamic positioning thrusters guided by satellites. Every detail must be engineered for survival. The rig must withstand Category 5 hurricanes, freezing Arctic storms, and saltwater corrosion. Safety is paramount. Escape pods, fire suppression systems, and blowout preventers are built into every design. Just building one mega rig can require 500,000 tons of steel, enough to construct several skyscrapers, and once complete, it can cost anywhere between $500 million to over $10 billion. And yet, this is only the beginning. The true mission, the drilling of oil, has yet to start. Imagine standing on a rig in the middle of the ocean and then drilling a hole straight down through 2 miles of water and several more miles of rock, salt, and sand, all to hit a reservoir no wider than a few hundred feet. That's the challenge engineers face. The process begins with a drill bit attached to a long string of pipe. The bit itself is a marvel. Tipped with industrial diamonds, it spins at thousands of rotations per minute, grinding through rock like butter. As it drills, drilling mud, a mixture of water, clay, and chemicals, is pumped down the pipe. This mud lubricates the bit, cools it, and carries rock cuttings back to the surface. More importantly, it provides pressure to keep oil and gas from surging uncontrollably upward. The drill advances foot by foot, while sensors send real-time data to engineers in control rooms filled with glowing monitors. These specialists can adjust direction mid-drill, steering the bit horizontally to tap into reservoirs miles away. This technique, called directional drilling, revolutionized the industry, allowing rigs to access vast amounts of oil from a single location. Once the target reservoir is reached, steel casing pipes are inserted into the hole and cemented in place to stabilize the well. Then comes the installation of a blowout preventer, a massive stack of valves weighing hundreds of tons, designed to seal the well in an emergency. When everything is secure, the drilling mud is replaced and the reservoir is opened. Suddenly, oil and gas, trapped under immense pressure for millions of years, flow upward through the wellbore. Pumps and separators on the rig capture this flow, separating crude oil from natural gas and water. A single well can produce tens of thousands of barrels of oil per day, and one rig may drill multiple wells over its lifetime. In fact, the world's largest rigs can produce up to 250,000 barrels per day, enough to fuel 10 million cars daily. But drilling is only half the story. The oil must then be processed, stored, and transported across the globe, a supply chain as vast and complex as the rigs themselves. For the workers, life on a mega oil rig is unlike anywhere else. Crews typically work 12-hour shifts 7 days a week, for weeks at a time, before rotating back home. Life revolves around strict schedules. Workers wake early, grab a quick breakfast in the cafeteria, then head to their stations, whether it's on the drill floor, in the engine room, or maintaining safety systems. The work is demanding, noisy, and often dangerous, but teamwork and discipline keep operations running smoothly. Once oil is extracted, it must be processed. On board the rig, separation units remove water and gas from the crude. The oil is stored in massive tanks within the rig's hull, or pumped directly into pipelines that stretch across the seafloor, sometimes for hundreds of miles, to reach the mainland. Natural gas, separated from the oil, is often compressed and transported through pipelines or burned off in flares, those bright flames you sometimes see at rigs. Though newer rigs aim to capture and use it more efficiently. From the rig, oil travels to refineries, where it's transformed into gasoline, diesel, jet fuel, plastics, and thousands of other products. Every step of this journey is monitored by sophisticated systems to prevent spills and leaks, because a single accident can devastate marine ecosystems. The logistics are staggering. A large rig might fill a tanker ship every few days, with each ship carrying up to 2 million barrels of oil. That's enough to supply an entire country's energy needs for weeks. The world consumes about 100 million barrels of oil every day, and offshore fields provide nearly a third of that supply. As long as demand continues, engineers will keep pushing the boundaries of what's possible in the depths of the ocean. If this journey into the world of mega oil rigs amazed you, don't forget to hit that like button, subscribe, and turn on the notification bell. Your support helps us bring more mind-blowing stories of engineering, industry, and the hidden systems that power our world. Thanks for watching, and until next time, stay curious. Sand is the single most consumed natural resource on Earth after water. Every year, humanity uses over 50 billion tons of sand, enough to build a wall 27 meters high and 27 meters wide all the way around the planet. Sand. At first glance, it seems so ordinary, so plentiful, so insignificant. After all, it's just tiny grains of rock scattered across beaches, deserts, and riverbeds. But how do we actually harvest this vast quantity of sand? What does supergiant sand mining look like, and what secrets does it hold? In this video, we'll take you inside the billion-dollar industry that extracts, processes, and transports unimaginable amounts of sand every year. You'll discover how sand is mined from rivers, quarries, and seabeds. how it's sorted, washed, and transformed into essential building blocks of our lives, and why this seemingly abundant resource is becoming one of the most contested commodities in the world. Before we dive in, make sure to like, subscribe, and hit the notification bell so you never miss our behind-the-scenes deep dives into the industries that shape our world. Now, let's uncover the billion-dollar secret of sand. Not all sand is usable. Desert sand, for example, is too smooth and rounded from wind erosion. Construction requires angular sand grains that lock together like puzzle pieces. That's why most of the sand we use comes from rivers, lakes, and coastal deposits, where water action creates sharp,